Section 8. Robot Construction Rules. The rules listed below explicitly address legal parts and materials and how those parts and materials may be used on a Reefscape robot. A robot is an electromechanical assembly built by the FRC robotics competition team to play the current season's game and includes all the basic systems required to be an active participant in the game: power, communication, control, bumpers, and movement about the field. A bumper is a protective assembly designed to attach to the exterior of the robot and constructed as specified in Section 8.4 Bumper Rules. There are many reasons for the structure of the rules, including safety, reliability, parity, creation of a reasonable design challenge, adherence to professional standards, impact on the competition, and compatibility with the kit of parts, KOP. The KOP is the collection of items listed on the current season's kickoff kit checklists, distributed to the teams via first choice in the current season, or paid for completely except shipping with a product donation voucher, PDV, from the current season. Another intent of these rules is to have all energy sources and active actuation systems on the robot, e.g. batteries, compressors, motors, servos, cylinders, and their controllers, drawn from a well-defined set of options. This is to ensure that all teams have access to the same actuation resources and that the inspectors are able to accurately and efficiently assess the legality of a given part. Robots are made up of components and mechanisms. A component is any part in its most basic configuration which cannot be disassembled without damage or destroying the part or altering its fundamental function. A mechanism is an assembly of components that provide specific functionality on the robot. A mechanism can be disassembled and then reassembled into individual components without damage to the parts. Many rules in this section reference commercial off-the-shelf COTS items. A COTS item must be a standard, i.e. not custom order, part commonly available from a vendor for all teams for purchase. To be a COTS item, the component or mechanism must be in an unaltered, unmodified state, with the exception of installation or modification of any software. Items that are no longer commercially available but are functionally equivalent to the original condition as delivered from the vendor are considered COTS and may be used. Blue box. Example 1. A team orders 2 robot grippers from RoboHand Corp. And receives both items. They put one in their storeroom and plan to use it later. Into the other, they drill lightning holes to reduce weight. The first gripper is still classified as a COTS item, but the second gripper is now a fabricated item as it has been modified. Example 2. A team obtains openly available blueprints of a drive module commonly available from Wheels R Us Inc. and has local machine shop We Make It Inc. manufacture a copy of the parts for them. The produced part is not a COTS item because it is not commonly carried as part of the standard stock of We Make It Inc. Example 3. A team obtains openly available design drawings from a professional publication during the preseason and uses them to fabricate a gearbox for the robot during the build period following kickoff. The design drawings are considered a COTS item and may be used as raw material to fabricate the gearbox. The finished gearbox itself would be a fabricated item and not a COTS item. Example 4. A COTS part that has non-functional label markings added would still be considered a COTS part, but a COTS part that has device-specific mounting holes added is a fabricated item. Example 5. A team has a COTS single-board processor version 1.0, which can no longer be purchased. Only the COTS single-board processor version 2.0 may be purchased. If the COTS single-board processor version 1.0 is functionally equivalent to its original condition, it may be used. Example 6. A team has a COTS gearbox which has been discontinued. If the COTS gearbox is functionally equivalent to its original condition, it may be used. A vendor is a legitimate business source for COTS items that satisfies all the following criteria. A. Has a federal tax identification number. In cases where the vendor is outside the United States, they must possess an equivalent form of registration or license with the government of their home nation that establishes and validates their status as a legitimate business licensed to operate within that country. B. Is not a wholly owned subsidiary of a FRC robotics competition team or collective of teams. While there may be some individuals affiliated with both a team and the vendor, the business and activities of the team and vendor must be completely separable. C. Should maintain sufficient stock or production capability so they are able to ship any general, i.e. non-first unique product within 5 business days of receiving a valid purchase request. It is recognized that certain unusual circumstances, such as a global supply chain disruption and/or 1,000 FIRST teams all ordering the same part at once from the same vendor may cause atypical delays in shipping due to back orders for even the largest vendors. Such delays due to higher than normal order rates are excused. The criterion may not apply to custom-built items from a source that is both a vendor and a fabricator. Blue box. For example, a vendor may sell flexible belting that the team wishes to procure to use as treads on their drive system. The vendor cuts the belting to a custom length from standard shelf stock that is typically available, welds it into a loop to make a tread, and ships it to the team. The fabrication of the tread takes the vendor 2 weeks. This would be considered a fabricated item, and the 2-week ship time is acceptable. Alternatively, the team may decide to fabricate the treads themselves. To satisfy this criterion, the vendor would just have to ship a length of belting from shelf stock, i.e. a COTS item, to the team within 5 business days and leave the welding of the cuts to the team. D. Makes their products available to all FIRST Robotics competition teams. A vendor must not limit supply or make a product available to just a limited number of FIRST Robotics competition teams. Blue box. The intent of this definition is to be as inclusive as possible to permit access to all legitimate sources, while preventing ad hoc organizations from providing special-purpose products to a limited subset of teams in an attempt to circumvent the cost accounting rules. FIRST desires to permit teams to have the broadest choice of legitimate sources possible and to obtain COTS items from the sources that provide them with the best prices and level of service available. Teams also need to protect against long delays in availability of parts that will impact their ability to complete their robot. The build season is brief, so the vendor must be able to get their product, particularly FIRST unique items, to a team in a timely manner. Ideally, chosen vendors should have national distributors, e.g. Home Depot, Lowe's, MSC, McMaster-Carr, etc. Remember, FIRST Robotics competition events are not always near home. When parts fail, local access to replacement materials is often critical. A fabricated item is any component or mechanism that has been altered, built, cast, constructed, concocted, created, cut, heat-treated, manufactured, machined, modified, painted, produced, surface-coated, or conjured partially or completely into the final form in which it will be used on the robot. Blue box. Note that it is possible for an item, typically raw materials, to be neither COTS nor a fabricated item. For example, a 20-foot length of aluminum which has been cut into 5-foot pieces by the team for storage or transport is neither COTS, it's not in the state received from the vendor, nor a fabricated item. The cuts were not made to advance the part towards its final form on the robot. Teams may be asked to provide documentation proving the legality of non-reefscape kit of parts items during inspection, where a rule specifies limits for a legal part, e.g. pneumatics items, current limits, COTS, electronics, etc. Some of these rules make use of English unit requirements for parts. If your team has a question about a metric part equivalence legality, please email your question to the FIRST Robotics Competition Kit of Parts team at frcparts@firstinspires.org for an official ruling. To seek approval for alternate devices for inclusion in future FIRST Robotics Competition seasons, please contact the Kit of Parts team at frcparts@firstinspires.org with item specifications. Teams should acknowledge the support provided by the corporate sponsors and mentors with an appropriate display of their school and sponsor names and/or logos, or the name of the supporting youth organization if appropriate. FIRST Robotics Competition can be a full contact competition and may include rigorous gameplay. While the rules aim to limit severe damage to robots, teams should design their robots to be robust. 8.1 General Robot Design. R101. Robot perimeter must be fixed. The robot, excluding bumpers, must have a robot perimeter contained within the bumper zone and established while in the robot's starting configuration. That is comprised of fixed, non-articulated structural elements of the robot. Minor protrusions no greater than a quarter inch, such as bolt heads, fastener ends, weld beads, and rivets, are not considered part of the frame perimeter. Blue box. To determine the robot perimeter, wrap a piece of string around the outermost part of the robot, excluding bumpers, at the bumper zone described in R405 and pull it taut. The string outlines the robot perimeter. Example: a robot's chassis is shaped like the letter U, with a large gap between chassis elements on the front of the robot. When wrapping a taut string around this chassis, the string extends across the gap and the resulting robot perimeter is a rectangle with 4 sides. R102. Starting configuration, no overhang. In the starting configuration, the physical configuration in which a robot starts a match, No part of the robot shall extend outside the vertical projection of the robot perimeter, with the exception of its bumpers and minor protrusions such as bolt head, fastener ends, rivets, cable ties, etc. Blue box. If a robot is designed as intended and each side is pushed up against a vertical wall in starting configuration and with bumpers removed, only the robot perimeter or minor protrusions will be in contact with the wall. The allowance for minor protrusions in this rule is intended to allow protrusions that are both minor in extension from the robot perimeter and cross-sectional area. If a robot uses interchangeable mechanisms per I-103, teams should be prepared to show compliance with this rule and R-105 in all configurations. R-103, robot weight limit. The robot weight must not exceed 115 pounds. When determining weight, the basic robot structure and all elements of all additional mechanisms that might be used in a single configuration of the robot shall be weighed together, see I-103. For the purposes of determining compliance with the weight limitations, the following items are excluded. A. Robot bumpers. B. Robot battery and its associated half of the Anderson cable quick connect/disconnect pair, including no more than 12 inches of cable per leg, the associated cable lugs, connecting bolts, and insulation. And C. Tags used for location detection systems if provided by the event. R-104. Starting configuration max size. A robot starting configuration may not have a robot perimeter greater than 120 inches and may not be more than 3 feet 6 inches tall. Blue box. Be sure to consider the size of the robot on its cart to make sure it will fit through the doors. Also consider the size of the robot to ensure that it will fit into a shipping crate, vehicle, etc. Note that rules contained in Section 8.4 bumper rules may impose additional restrictions on robot design. R-105, robot extension limit. Robots may not extend more than 1 foot 6 inches beyond the vertical projection of their robot perimeter. Blue box. Teams should expect to have to demonstrate a robot's ability to constrain itself per above during inspection. Constraints may be implemented with either hardware or software. See Section 7.4.3 Robot for height and extension restrictions for various areas of the field. 8.2 Robot safety and damage prevention. R-201, no digging into carpet. Traction devices must not have surface features that could damage the arena, e.g. metal, sandpaper, inflexible studs, cleats, hook loop fasteners, or similar attachments. Traction devices include all parts of the robot that are designed to transmit any propulsive and/or braking force between the robot and the field carpet. R-202, no exposed sharp edges. Protrusions from the robot and exposed surfaces on the robot shall not pose hazard to the arena elements, including scoria elements or people. R-203, general safety. Robot parts shall not be made from hazardous materials, be unsafe, cause an unsafe condition, or interfere with the operation of other robots. Blue box. Example of items that will violate this rule include, but are not limited to, A. Shields, curtains, or any other device or material designed or used to obstruct or limit the vision of any drive team members and or interfere with their ability to safely control their robot. B. Speakers, sirens, air horns, or other audio devices that generate sound at a level sufficient to be a distraction. C. Any devices or decorations specifically intended to jam or interfere with the remote sensing capabilities of another robot, including vision systems, acoustic rangefinders, sonars, infrared proximity detectors, etc., e.g., including imagery on your robot that utilizes or closely mimics 36H11 April tags. D. Exposed lasers other than Class 1. E. Flammable gases. F. Any device intended to produce flames or pyrotechnics. G. Hydraulic fluid or hydraulic items. H. Switches or contacts containing liquid mercury. I. Circuitry used to create voltages in excess of 24 volts. J. Any ballast not secured sufficiently, including loose ballast, e.g. sand, ball bearings, etc., such that it may become loose during a match. K. Exposed, untreated hazardous materials, e.g. lead weights, used on the robot. These materials may be permitted if painted, encapsulated, or otherwise sealed to prevent contact. These materials may not be machined in any way at an event. L. Tire sealant, and M. High-intensity light sources used on the robot, e.g. super bright LED sources marketed as military grade or self-defense, may only be illuminated for a brief time while targeting and may need to be shrouded to prevent an exposure to participants. Complaints about the use of such light sources will be followed by reinspection and possible disablement of the device. R-204. Leave scoring elements at the field. Robots must allow removal of scoring elements from the robot and the robot from the field elements while disabled and powered off. Blue box. Robots will not be re-enabled after the match, so teams must be sure that scoring elements and robots can be quickly, simply, and safely removed. Teams are encouraged to consider G501 when developing their robots. R205. Don't contaminate the field. Lubricants may be used only to reduce friction within the robot. Lubricants must not contaminate the field or other robots. R206. Don't damage scoring elements. Robot elements likely to come in contact with the scoring element shall not pose a significant hazard to the scoring element. Blue box. Scoring elements are expected to undergo a reasonable amount of wear and tear as they are handled by robots, such as scratching or marking, gouging, tearing off pieces, or routinely marking scoring elements are violations of this rule. 8.3. Budget constraints and fabrication schedule. R301. Individual item cost limit. No individual non-KOP item or software shall have a fair market value FMV that exceeds $600 US. The total cost of components purchased in bulk may exceed $600 USD as long as the cost of an individual component does not exceed $600 USD. Blue box. Teams should be ready to show inspectors documentation of fair market value for any components that appear to be in the range of the 600 USD limit. The Analog Devices IMU MXP breakout board, part number ADIS 16448, does not have a published fair market value. This device is considered to comply with this rule regardless of its true FMV. The FMV of a COTS item is its price defined by a vendor for the part or an identical functional replacement. This price must be generally available to all FIRST robotic competition teams throughout the build season and competition season, i.e., short-term sale prices or coupons do not reflect fair market value. However, teams are only expected to make a good faith effort at determining the item price and are not expected to monitor prices of robot items throughout the season. The FMV is the cost of the item itself and does not include any duties, taxes, tariffs, shipping, or other costs that may vary by locality. The FMV of a COTS software is the price set by the vendor to license the software or piece of the software that runs on the robot for the period from kickoff to the end of the first championship. The FMV of software licensed free of cost, including through the virtual kit of parts, for its use on the robot is $0. The FMV of a fabricated parts is the value of the material and or labor, except for labor provided by team members, including sponsor employees who are members of the team, members of other teams, and or event-provided machine shops. Material costs are accounted for as the cost of any purchasable quantity that can be used to make the individual part, i.e. the purchasable raw material is larger than the fabricated part. Example 1. A team orders a custom bracket made by a company to the team's specification. The company's material costs and normally charged labor rate apply. Example 2. A team receives a donated sensor. The company would normally sell this item for $450 USD, which is therefore its FMV. Example 3. A team purchases titanium tube stock for $400 USD and has it machined by a local machine shop. The machine shop is not considered a team sponsor but donates 2 hours of expended labor anyway. The team must include the estimated normal cost of the labor as if it were paid to the machine shop and add it to the $400 USD. Example 4. A team purchases titanium tube stock for $400 USD and has it machined by a local machine shop that is a recognized sponsor of the team. If the machinists are considered members of the team, their labor costs do not apply. The total applicable cost for the part would be $400 USD. It is in the best interests of the teams and FIRST to form relationships with as many organizations as possible. Recognizing supporting companies as sponsors of and members in the team is encouraged, even if the involvement of the sponsor is solely through the donation of fabrication labor. Example 5. A team purchases titanium tube stock for $400 USD and has it machined by another team. The total applicable cost for the part would be $400 USD. Example 6. A team purchases a widget at a garage sale or online auction for $300, but it's available for sale from a vendor for $700. The FMV is $700. If a COTS item is part of a modular system that can be assembled in several possible configurations, then each individual module must fit within the price constraints defined in this rule. If the modules are designed to assemble into a single configuration and the assembly is functional in only that configuration, then the total cost of the complete assembly, including all modules, must fit within the price constraints defined in this rule. In summary, if a vendor sells a system or kit, a team must use the entire system/kit's FMV and not the value of its component pieces. Example 7. Vendor A sells a gearbox that can be used with a number of different gear sets and can mate with 2 different motors they sell. A team purchases the gearbox, a gear set, and a motor, then assembles them together. Each part is treated separately for the purposes of determining FMV, since the purchased pieces can each be used in various configurations. Example 8. Vendor B sells a robotic arm assembly that a team wants to use. However, it costs $630 USD, so they cannot use it. The vendor sells the hand, wrist, and arm as separate assemblies for $210 USD each. A team wishes to purchase the 3 items separately, then reassemble them. This would not be legal, as they are really buying and using the entire assembly, which has a fair market value of $630 USD. Example 9. Vendor C sells a set of wheels or wheel modules that are often used in groups of 4. The wheels or modules can be used in other quantities or configurations. A team purchases 4 and uses them in the most common configuration. Each part is treated separately for the purposes of determining FMV, since the purchased pieces can be used in various configurations. R302. Major mechanism from this year only. Major mechanisms as defined in I-101 created before kickoff are not permitted. Blue box. Neither this rule nor the language in this blue box defines specific thresholds for how much of a major mechanism must be constructed after kickoff. This rule expects and requires the team's honest assessment of whether they built the major mechanism of their robot after kickoff. Attempts to exploit loopholes in the definition of major mechanism in order to bypass this requirement are in the spirit of neither this rule nor first robotics competition. Examples of exploitation include: A. Pre-assembling significant portions of a major mechanism prior to kickoff and attaching those assemblies together post-kickoff. B. Removing a small component of a major mechanism prior to kickoff such that it is no longer a major mechanism and replacing it after kickoff. R303. Create new designs and software unless they're public. Robot software and designs created before kickoff are only permitted if the source files, complete information sufficient to produce the design, are available publicly prior to kickoff. Blue box. Example 1. A team realizes that the transmission designed and built in the fall perfectly fits their need for a transmission to drive the robot arm. They built an exact copy of the transmission from the original design plans and bolted it to the robot. This would be prohibited as the transmission, although made during the competition season, was built from detailed designs developed prior to kickoff. Example 2. A team developed an omnidirectional drive system for the 2019 competition in July 2019. They refined and improved the control software written in C++ to add more precision and capability. They decided to use a similar system for the Reefscape competition. They copied large sections of unmodified code over into the control software of the new robot, also written in C++. This would be a violation of the schedule constraint and is not allowed. Example 3. The same team decides to use LabVIEW as their software environment for Reefscape. Following kickoff, they used the previously developed C++ code as a reference for the algorithms and calculations required to implement their omnidirectional control solution. Because they developed new LabVIEW code as they ported over their algorithms, this is permitted. Example 4. A different team develops a similar solution during the fall and plans to use the developed software on their competition robot. After completing the software, they post it in a generally accessible public forum and make the code available to all teams. Because they have made their software publicly available before kickoff, they can use it on their robot. Example 5. A team develops a transmission prior to kickoff. After completing the project, they publish the CAD files on a generally accessible public forum and make them available to all teams. Because they have made the design publicly available before kickoff, they can use the design to create an identical transmission fabricated after kickoff for use on the Reefscape robot. R304. During an event, only work during pit hours. During an event, a team is intending, regardless of whether the team is physically at the event location, the team may neither work on nor practice with their robot or robot elements outside of the hours that pits are open, with the following exceptions. A. Operator consoles, bumpers, battery assemblies as described in R103-B. B. COTS items with minor modifications, attachment of connectors, assembly of COTS items per manufacturer instructions, labeling or decorations, etc. C. Software development. And D. Charging batteries. Blue box. For the purposes of this rule, official events begin as follows. Regionals, district championships, and first championship at the start of the first designated load-in period according to the public schedule. If the public schedule is not available or there is no designated load-in period, the event begins at 4 p.m. on the day prior to pits opening. District events when pits open. Examples of activity prohibited by this rule include A. Working on the robot at the team shop after load-in for the event has begun. B. Working on robot parts at night at the team's hotel. C. Running a 3D printer or other automated manufacturing process overnight producing robot parts. Note that E107 and E401 impose additional restrictions on work done on the robot or robot materials while attending an event. This rule is intended to increase equity between teams with significant travel to an event and those nearby. Close teams would otherwise have an advantage by being able to work on the robot in their shop until it's time to go to the event. 8.4. Bumper rules. A bumper is a required assembly which attaches to the robot frame. Bumpers protect robots from damaging/being damaged by other robots and field elements. A bumper guide providing additional information on materials and design based on historical best practices may be found under the Mechanical Resources section of the Technical Resources page. Teams may also reference the kit bot instructions for a detailed step-by-step on how to build bumpers for the kit bot. All dimensions specified in this section are nominal and will be measured during inspection with a tolerance of 1/4 inch, unless otherwise specified. This means that maximums specified have a tolerance of +1/4 inch, and minimums specified have a tolerance of -1/4 inch. Teams are encouraged to design to the nominal dimensions and reserve the tolerance for unexpected deviations such as manufacturing error or tolerance stack-up. R401, bumpers all around. Robots are required to use bumpers to protect the entire robot perimeter. Gaps of less than 1¼ inches between adjacent segments are permitted as long as corners are filled per R406. R402. Bumper construction. Bumpers must consist of the following. A. Padding. A minimum of 2¼ inch depth of foam padding, at least 4½ inches tall, consisting of solid blocks, sheets, or stacked rods of one or more of the following materials. 1. Pool noodles, hollow or solid or backer rod. 2. Solid polyethylene closed cell foam with density between 1.5 and 3 pounds per cubic foot. 3. Solid EVA closed cell foam with density between 2 and 6 pounds per cubic foot. 4. Foam floor tiles. Multiple types, shapes, and or layers of foam may be used within a single bumper. Blue box. Teams should be prepared to provide information about the padding material used in their bumpers. Teams do not need to have a separate material sample or exposed padding for direct inspection to show compliance with this rule. B. Backing. A backer of at least 4½ inches tall, which supports the padding, i.e. padding is not cantilevered other than in corners, and facilitates installation and removal of the bumper from the robot as noted in R410. Additional elements may be added to strengthen the backing, fill space between the bumper and robot frame, or serve as part of the attachment system. C. Cover. Fabric as noted in G411, which covers all outward, upward, and downward facing surfaces such that no padding is exposed to interaction with the field or other robots. D. Fastening system. Bumpers must attach to the robot perimeter with a rigid fastening system to form a tight, robust connection to the main structure, frame, etc., e.g. not attached with hook and loop tape, or cable ties. The fastening system must be designed to withstand vigorous gameplay. All removable fasteners, e.g. bolts, locking pins, quick-release pins, etc., may be considered part of either the bumper or robot for determination of weight per R103 and R408. Blue box. The bumper rules provided teams significant freedom in choosing designs and materials. For information on a reference design, see the bumper guide under the Mechanical Resources section of the Technical Resources page. R403. Bumper extension limit. Bumpers must not extend more than 4 inches from the robot perimeter. R404. Bumpers must be soft. Hard parts of bumpers must not extend more than 1¼ inches from the robot perimeter. Padding must extend at least 2 inches beyond any hard parts of the bumper. Blue box. Hard parts include any items which are likely to cause damage to the fabric or padding of other bumpers such as nuts, bolts, cable ties, hard plastic, etc. R405. Bumpers interact with bumpers. Padding per R402-A supported by backing per R402-B must entirely fill the bumper zone, a space between 2.5 inches and 5 3/4 inches from the floor. Blue box. This measurement is intended to be made as if the robot is resting on a flat floor without changing the robot configuration, not relative to the current height of the robot from the field carpet at any given time. Examples include, Example 1. A robot that is at an angle while navigating the field has its bumpers outside the bumper zone. If this robot were virtually transposed onto a flat floor and its bumpers are in the bumper zone, it meets the requirements of this rule. Example 2. A robot deploys a mechanism which lifts the robot bumpers outside the bumper zone when virtually transposed onto a flat floor. This violates this rule. R406. Fill bumper corners. Corner joints between bumpers must be filled with uncompressed padding material extending at least 2.25 inches from the corner with no gaps or voids. Examples of implementation are shown in Figure 8-7. Blue box. Examples that do not meet the requirement of R406. A. Foam cylinders or sheets bent around a sharp corner less than 135 degrees are considered compressed. B. Separate bumper segments meeting at a miter in the corner are not considered to fill the corner due to the fabric covering. R407. Bumpers shouldn't be wedges. Bumpers must not act as wedges when interacting with other bumpers. Blue box. Examples of bumpers which act as wedges include A. Bumpers utilizing softer foam towards the top of a bumper profile. B. Bumpers utilizing excessively rounded profiles such as a single semicircle. C. Bumpers with significantly rounded profiles near the top of the bumper zone, e.g. placing the top of a foam cylinder such that it ends right at or just above the bumper zone. D. Bumpers with tapered or stepped padding such that the padding is thinner or thicker towards the top or bottom. R408. Weight limit with bumpers. The total weight of the robot as described in R103 with bumpers must not exceed 135 pounds. R409. Bumpers shouldn't move. Bumpers must not be articulated relative to the robot perimeter. R410. Bumpers must come off. Bumpers must be designed for installation and removals to facilitate inspection and weighing. Blue box. As a guideline, bumpers should be able to be installed or removed by 2 people in fewer than 5 minutes. R411. Bumpers indicate your alliance. Each robot must be able to display red or blue bumpers to reflect their alliance color, as assigned in the match schedule distributed at the event, as described in Section 10.1 Match Schedules. Contrasting markings on outward-facing surfaces of the bumper other than the following are prohibited. A. Those required per R412. B. Hook and loop tape, snap fasteners, or functional equivalents backed by the hard parts of the bumper. C. Solid white first logos between 4 3/4 inch and 5 1/4 inch wide, i.e. comparable to those available in the Reefscape virtual kit. And D. Narrow areas of underlying fabric exposed at seams, corners, or folds. R412. Team number on bumpers. Team numbers must be displayed and positioned on the bumpers such that an observer walking around the perimeter of the robot can unambiguously tell the team's number from any point of view, from as far as approximately 60 feet, and meet the following additional criteria. A. Consist of only white Arabic numerals at least 3 3/4 inches high, at least a ½ inch in stroke width. Blue box. The ½ inch stroke width requirement applies to the majority of the stroke. Font elements less than a ½ inch, such as serifs, rounded edges, small hairline or gaps, etc., are permitted as long as the majority of the stroke meets the sizing requirements and the numbers are unambiguous. B. Must not wrap around sharp corners less than 135 degrees of the robot perimeter. C. Must not split individual digits such that the team number is ambiguous. And blue box. As a guideline, spacing between digits or groups of digits which exceed 4 inches may be ambiguous. D. Must not substitute logos or icons for numerals. Blue box. There is no prohibition against splitting team numbers onto different sections of bumper. The intent is that the team's number is clearly visible and unambiguous so that judges, referees, announcers, and other teams can easily identify competing robots. This marking is intended to display the team's number only, not to intentionally change the surface characteristics of the bumper. Excessive material usage as part of any team numbers marking will invite close scrutiny. 8.5. Motors and actuators. R501. Allowable motors. The only motors and actuators permitted include the following, in any quantity: AndyMark 915, AndyMark Neverest, AndyMark PG, AndyMark Redline motor, AndyMark Snowblower motor, Banebots, a bunch of different types, Sims, CTR Electronics Minion, CTR/Vex Robotics Falcon 500, current/former kit of parts automotive motors, Nidec Dynamo BLDC motor, playing with Fusion Venom, Rev Robotics HD Hex, Rev Robotics Neo Brushless, Rev Robotics Neo 550, Rev Robotics Neo Vortex, Vex Bag, Vex Minisim, WCP Kraken X44, West Coast Products, or WCP Kraken X60, West Coast Products RS775 Pro, fans no greater than 120 millimeters, and rated electrical input power no greater than 10 watts, continuous duty at 12 volts, hard drive motors, part of a legal COTS computing device, factory installed vibration and autofocus motors resident in COTS computing devices, e.g. rumble motors in a smartphone, PWM COTS rotational servos with stall currents less than or equal to 4 amps and mechanical output power less than or equal to 8 watts at 6 volts. PWM COTS linear servos with max stall current less than or equal to 1 amp at 6 volts. Motors integral to a COTS sensor, e.g. lidar, scanning sonar, etc., provided the device is not modified except to facilitate mounting. One compressor compliant with R806 and used to compress air for the robot's pneumatic system. COTS linear actuators, electric solenoids actuators, or electromagnets rated for 12 volts and wired downstream of a breaker 20 amps or less. Electrical solenoid actuators or electromagnets used at 24 volts must be rated for 24 volts. Blue box. For servos, note that the RoboRio is limited to a max current output of 2.2 amps on the 6-volt rail, 12.4 watts of electrical input power. Teams should make sure that their total servo power usage remains below this limit at all times. Servo mechanical output power is approximated by the following formula using 6-volt data reported by manufacturer. Mechanical output power in watts is 0.25 times the stall torque in Newton meters times the no-load speed in radians per second. This calculator from the first Tech Challenge documentation can be used to help calculate output power from inputs of various units. Given the extensive amount of motors allowed on the robot, teams are encouraged to consider the total power available from the robot battery during the design and build of the robot. Drawing large amounts of current from multiple motors at the same time could lead to drops in robot battery voltage that may result in tripping the main breaker or triggering the brownout protection of the RoboRio. For more information about the RoboRio brownout protection and measuring current draw using the PDP/PDH, see RoboRio brownout and understanding current draw. AndyMark PG gear motors are sold with labeling based on the entire assembly. Assemblies labeled AM3651 through AM3656 contain legal motors specified in Table 8-1. These motors may be used with or without the provided gearbox. R502. Only 4 propulsion motors. A robot may not have more than 4 propulsion motors. A propulsion motor is a motor that enables the robot to move around the field surface. Motors that generate small amounts of thrust as a secondary or incidental feature are not considered propulsion motors. Blue box. Examples that are not considered propulsion motors include A. Motors that primarily alter the alignment of a wheel in contact with the field surface, such as swerve steering motors. B. Motors that run mechanism wheels, e.g. coral manipulation, that occasionally happen to contact the carpet, but without enough force to generate significant thrust. And C. Motors that change the speed of the drive wheels using a shifting mechanism without significantly contributing to propulsion. R503. Don't modify motors mostly. The integral mechanism and electrical system of any motor must not be modified. Motors, servos, and electric solenoids used on the robot shall not be modified in any way except as follows. A. Mounting brackets and/or output shafts/interface may be modified to facilitate the physical connection of the motor to the robot and actuated part. B. The electrical leads may be trimmed to length as necessary, and connectors or splices to additional wiring may be added. C. The locking pins on the window motors may be removed. D. The connector housing on Kiddo Parts automotive motors listed in Table 8-1 may be modified to facilitate lead connections. E. Servos may be modified as specified by the manufacturer, e.g. reprogramming or modification for continuous rotation. F. The wiring harness of the NIDAC Dynamo BLDC motor may be modified as documented by FIRST in NIDAC Dynamo BLDC motor with controller. G. Minimal labeling may be applied to indicate device purpose, connectivity, functional performance, etc. H. Any number of 1032 plug screws may be removed from the Falcon 500 and the Kraken X60. I. Insulation may be applied to electrical terminals. J. Repairs provided the original performance and specifications are unchanged. K. Maintenance recommended by the manufacturer. And blue box. The intent of this rule is to allow teams to modify mounting tabs and the like, not to gain a weight reduction by potentially compromising the structural integrity of any motor. R504. Power most actuators off of approved devices. With the exception of servos, fans, or motors integral to sensors of COTS computing devices permitted in R501, each actuator must be controlled by a power-regulating device. The only power-regulating devices for actuators permitted on the robot include A. Motor controllers. There's a whole list of motor controllers, some integrated with the Kraken or Falcon. B. Relay modules, Spike H-Bridge, Automotion Direct Relays, Power Distribution Hub, switches, etc. C. Pneumatics controllers, A. Pneumatic Control Module, PCM, or B. The Pneumatics Hub. D. Servo controllers, the Servo Hub, part number Rev 11-1855, blue box. Note, the Automation Direct Relays are single directional. Per R504, they may not be wired together in an attempt to provide bidirectional control. R505, don't overload controllers. Each power regulating device may control electrical loads per Table 8-2. Unless otherwise noted, each power regulating device shall control one and only one electrical load. And then it lists all of the power regulating devices and how many things they can control, or how many motors, different motors have different limits on how many you can assign to each power regulating device. R506, control servos safely. Servos must be connected to and only to one of the following. A. PWM ports on the Robo Rio. B. PWM ports on a WCP Spartan sensor board. C. Rev Robotics Servo Power Module. D. Rev Robotics Servo Hub. 8.6 Power Distribution. In order to maintain safety, the rules in this section apply at all times while at the event, not just while the robot is on the field for matches. R601 Battery Limit. Everyone has the same power. The only legal source of electrical energy for the robot during the competition, the robot battery, must be one and only one non-spillable sealed lead-acid SLA battery with the following specifications. A. Nominal voltage 12 volts. B. Nominal capacity at 20-hour discharge rate, minimum 17 amp hours, maximum 18.2 amp hours. C. Shape rectangular. D. Nominal dimensions 7.1 inches by 3 inches by 6.6 inches, plus or minus 0.1 inch for each dimension. E. Nominal weight 11 pounds to 14.5 pounds. F. Terminals nut and bolt style. Blue box. Nut and bolt style refers to any style battery terminal where the connector is secured to the battery using a threaded fastener. Examples of batteries which meet these criteria include Enersys part number, etc., MK battery part number ES17-12, etc., a bunch of different options. Teams should be aware that they may be asked to provide documentation of the specifications of any battery not listed above. Batteries should be charged in accordance with manufacturer's specification. Please see the FIRST Safety Manual for additional information. R602, other batteries for cameras or computers only. COTS USB battery packs with a capacity of 100 watt-hours or less, 27,000 milliamp hour at 3.7 volts with 5 volt/5 amp max output or 12 volt/5 amp max output using USB PD per port Batteries integral to and part of a COTS computing device or self-contained camera, e.g. laptop, battery, GoPro style camera, etc., or battery used to power CMOS/RTC features may be used to power COTS computing devices and any peripheral COTS input or output devices connected to the COTS computing device, provided they are A. securely fastened to the robot, B. connected only using unmodified COTS cables, and C. charged according to manufacturer recommendations. Blue box. A COTS computing device is a non-robo-RIO device used to process or collect sensor information. A smart flashlight is not a COTS computing device. R603. Charge batteries with safe connectors. Any battery charger used to charge a robot battery must have the corresponding Anderson SB connector installed. R604. Charge batteries at a safe rate. Any battery charger used to charge a robot battery may not be used such that it exceeds 6 amp average charge current. R605. Batteries are not ballast. No batteries other than those allowed per R601 and R602 are allowed on the robot, whether or not they are being used to supply power. Blue box. For example, teams may not use additional batteries as extra weight on their robots. R606. Secure the battery. The robot battery must be secured such that it will not dislodge during vigorous robot interactions, including if the robot is turned over or placed in any arbitrary orientation. R607. Insulate battery connections. Each electrical terminal on the robot battery, main breaker, and their connections, lugs, strips, wire ends, etc., to the wire must be fully insulated at all times. R608. Limit non-battery energy. Non-electrical sources of energies used by the robot, i.e. stored at the start of a match, shall come only from the following sources. A. Compressed air stored in the pneumatic system that has been charged in compliance with R806 and R807. B. A change in the altitude of the robot center of gravity. C. Storage achieved by deformation of robot parts. D. Closed-loop COTS pneumatics gas shocks. Or E. Air-filled pneumatics wheels. R609. Connect main power safely. The following devices shall be connected with 6 AWG, 7 SWG, or 16 mm 2 squared copper wire or larger as shown in figure 8-9. A. 1 robot battery. B. A single pair of Anderson Power Products or APP 2-pole SB type connectors. C. The 1 main 120 amp surface mount circuit breaker with some part numbers available, and D, the 1 power distribution device, either the BDP 2.0, the PDH, etc. No additional devices or modifications shall be permitted with the following exceptions. E, monitoring circuitry permitted by R625, and F, SB50 or SB120 adapters, provided they have been presented for inspection. Blue box. SB type refers to SB type only, e.g. SB50 or SB120, etc., not SBS or any other part type beginning with SB. All batteries supplied by FRC, such as spare parts and international batteries, will have a red or pink SB50 connector installed, which may not be removed. The pink connectors included in the kit of parts mate with the red SB50 connector. R610, 1 breaker per circuit. All circuits, with the exception of those listed in R615 and R617, must connect to and have power solely by a single protected 12-volt DC WAGO connector pair, i.e. the load terminals as shown in figure 8-9 of the PDP/PDP 2.0/PDH, not the M6 cap screws. R611. The robot frame is not a wire. All wiring and electrical devices shall be electrically isolated from the robot frame. The robot frame must not be used to carry electrical current. Blue box. Compliance with this rule is checked by observing a greater than 120 ohm resistance between either the positive or negative post within the APP connector that is attached to the PDP/PDP 2.0/PDH and any point on the robot. All legal motor controllers with metal cases are electrically isolated. They may be mounted directly to robot frame components. Note that some cameras, decorative lights, and sensors, e.g. some encoders, some IR sensors, etc., have grounded enclosures or are manufactured with conductive plastics. These devices must be electrically isolated from the robot frame to ensure compliance with this rule. R612 must be able to turn robot on and off safely. The 120 amp circuit breaker must be quickly and safely accessible from the exterior of the robot. This is the only 120 amp circuit breaker allowed on the robot. Blue box. Examples considered not quickly and safely accessible include breakers covered by an access panel or door, or mounted on, underneath, or immediately adjacent to moving components. It is strongly recommended that the 120 amp circuit breaker location be clearly and obviously labeled so that it can be easily found by field staff if needed. While the main breaker must be accessible, consider positioning or shielding it such that it's protected from accidental actuation, e.g., it's unlikely to be hit by a scoring element during play. R613, electrical system must be inspectable. The PDP/PDP 2.0/PDH associated wiring in all circuit breakers must be visible for inspection. Blue box. Visible for inspection does not require that the item be visible when the robot is in its starting configuration, provided the team can make the items viewable during the inspection process. R614. No high voltage allowed. Any active electrical item that is not an actuator specified in R501 or core control system item specified in R710 is considered a custom circuit. Custom circuits shall not produce measurable voltages exceeding 24 volts with the exception of COTS power over Ethernet PoE injector devices used with COTS Ethernet cables and COTS receiving devices, i.e. not a breakout or adapter. R615. Power Robo-Rio as specified. The Robo-Rio power input must be connected to either A. the dedicated supply terminals on the PDB shown in Figure 8-9 or B. the terminals of one of the non-switchable fuse channels on the PDH with a 10 amp fuse or circuit breaker installed in the associated fuse holder, or C. directly to the terminals of any single channel on the PDP 2.0 with a 10 amp fuse or circuit breaker installed in the associated fuse holder. R616. Power radios as specified, Part 1. The wireless bridge radio power must be supplied by either A. the 12-volt 2-amp output of a CTR electronics voltage regulator module VRM, as shown in Figure 8-12, and must be the only load connected to those terminals, or B. using an Ethernet cable between a REV radio power module RPM and the Rio Ethernet port on the wireless bridge, or the 18 to 24 volt PoE port for events using OM5P radios, or C. directly from the PDP/PDP 2.0 PDH ports described in R617. This option is not permitted for OM5P radios. Blue box. Note that this prohibits using any other active PoE injector device to power the radio, but does not prohibit using any passive conductors to inject the VRM or direct PDP/PDP 2.0/PDH power into an Ethernet cable plugged into the radio power port labeled Rio. The use of a VRM or RPM to power the VH-109 radio is permitted in 2025 to allow transition to the new radio. In 2026, the radio will be required to be wired directly to the PDP/PDP 2.0/PDH. R617. Power radio as specified, Part 2. The device supplying power to the wireless bridge per R616 must be connected to either A. the designated supply terminals at the end of the PDP as shown in Figure 8-13, with the exception of a single CTR Electronics Pneumatics Control Module, PCM, or REV Robotics Hub, REV Pneumatics Hub. No other electrical loads shall be connected to these PDP terminals. B. The terminals of the non-switchable fuse channel on the PDH 20, 21, and 22 with a 10 amp fuse or circuit breaker installed in the associated fuse holder. No other electrical load shall be connected to that channel, or C. Directly to the terminals of any channel on the PDP 2.0 with a 10 amp fuse or circuit breaker installed on the associated fuse holder. Blue box, please reference how to wire an FRC robot for wireless bridge wiring information. R618. Use PDP/PDP 2.0/PDH terminals as designed. Only one wire shall be connected to each terminal on the PDP/PDP 2.0/PDH. Blue box. If multi-point distribution of circuit power is needed, e.g. to provide power to multiple PCMs and or VRMs from one 20 amp circuit, then all incoming wires may be appropriately spliced into a main lead, e.g. using an insulated terminal block, crimp splice, or soldered wire splice, and the single main lead inserted into the terminal to power the circuit. R619. Only use specified circuit breakers in PDP/PDP 2.0/PDH. The only circuit breakers permitted for use in the PDP/PDP 2.0/PDH are A. Snap Action VB3-A series or AT2-A terminal style F57 40 amp rating or lower. B. Snap Action MX5-A or MX5-L series 40 amp rating or lower. C. Rev Robotics ATO auto resetting breakers 40 amp rating or lower. D. Any ATM circuit breaker with value less than or equal to the fuses permitted per R620. R620. Only use specified fuses in PDP/PDP 2.0/PDH. The only fuses permitted for use in the PDP/PDP 2.0/PDH are mini automotive blade fuses with the following values. A. For the PDP, ATM-style fuses with values matching the value printed on the device's corresponding fuse holder. B. For the PDP 2.0, ATC/ATO-style fuses with values 10 amps or lower. And C. For the PDH, ATM-style fuses with values 15 amps or lower, with the exception of a single 20-amp fuse for powering a PCM or PH. Blue box. Note that these fuses must be pressed very firmly to seat properly. Improper seating can cause a device to reboot upon impact. R621. Protect circuits with appropriate circuit breakers. Each branch circuit must be protected by one and only one circuit breaker or fuse on the PDP/PDP 2.0/PDH per table A-3. No other electrical load can be connected to the breaker or fuse supplying this circuit with the exception of devices downstream of a Kraken X60 power pole adapter board, WCP 1380 or RF 4003. Table has motor controllers require up to 20 amp circuit, custom circuits up to 40 amp, and automation direct relay 40 amp. Fans permitted per R501 and not already part of CLOTS computing devices up to a 20 amp circuit, no limit of the number per breaker. Spike relay modules up to 20 amp circuit, one per circuit breaker/fuse. Automotive direct relay 25 amps can use an up to 20 amp breaker/fuse. PCM/PH with compressor up to 20 amp breaker/fuse, servo power module/servo hub up to 20 amp per fuse, additional VRM non-radio, additional PCM/PH non-compressor up to 20 amp circuit breaker/fuse, and up to 3 are allowed per breaker. Automation direct relay 12 amp, up to a 10 amp fuse/breaker, and only one is allowed per breaker/fuse. Blue box. This rule does not prohibit the use of smaller value breakers in the PDP/PDP 2.0/PDH or any fuses or breakers within custom circuits for additional protection. Fans permitted per R501 may also be included within custom circuits. R622. Use appropriately sized wire. All circuits shall be wired with appropriate sized insulation copper wire. Signal level cables don't have to be copper. For 31 to 40 amp breaker protection requires 12 AWG wire. For 21 to 30 amp breaker protected circuits required 14 AWG wire. For 6 to 20 amp breaker protected circuits or 11 to 20 amp fuse protected circuits, or between the PDP dedicated terminals and the VRM/RPM or PCM/PH, or compressor outputs from the PCM to PH, between the PDH and PCM/PH, between the PDP 2.0/PDH and the RoboRio. Not including between the PDP/PDH/PDP 2.0 and the RoboRio. Not including that one. All the others is 18 AWG wire. For between the PDP/PDP 2.0/PDH and the RoboRio, between the PDH and VRM/RPM, for Kraken X60 power pole adapter protected circuit, for less than or equal to 5 amp breaker protected circuits, or less than or equal to 10 amp fuse protected circuits, it requires 22 AWG wire. For the VRM 2 amp circuits, it requires 24 AWG wire. For RoboRio PWM port outputs, requires 26 AWG wire. For signal level circuits, i.e. circuits which draw less than or equal to 1 amp continuous and have a source incapable of delivering greater than 1 amp, including but not limited to RoboRio non-PWM outputs, CAN signals, PCM/PH solenoid outputs, VRM 500 milliamp outputs, RPM outputs, and Arduino outputs, requires 28 AWG wire. Wires that are recommended by the device manufacturer or originally attached to legal devices are considered part of the device and by default legal. Such wires are exempt from this rule provided they are powered by the smallest value fuse or breaker, which permits proper device operation. Blue box. In order to show compliance with these rules, teams should use wire with clearly labeled sizes if possible. If unlabeled wiring is used, teams should be prepared to demonstrate that the wire used meets the requirements of this rule, e.g. wire samples and evidence that they are the required size. R623. Use only appropriate connectors. Branch circuits may include intermediate elements such as COTS connectors, splices, COTS flexible/roiling/sliding contacts, and COTS slip rings, as long as the entire electrical pathway is via appropriately gauged/rated elements. Blue box. Slip rings containing mercury are prohibited per R203. R624. Use specified wire colors mostly. All non-signal level wiring with a constant polarity, i.e. except for outputs of relay modules, motor controllers, or sensors, shall be color-coded along their entire length from the manufacturer as follows. A. Red, yellow, white, brown, or black with stripe on the positive, e.g. plus 24 volt DC, plus 12 volt DC, or plus 5 volt DC, etc. connections. B. Black or blue from the common or negative side of the connections. Exceptions to this rule include C. Wires that are originally attached to legal devices and any extensions to these wires using the same color as the manufacturer, and D. Ethernet cables used in PoE cables. R625. Don't modify critical power paths. Custom circuits shall not directly alter the power pathways between the robot battery, PDP/PDP 2.0/PDH, motor controllers relays per R504-B, motors and actuators per R501, pneumatic solenoid valves, or other elements of the robot controlling systems, items explicitly mentioned in R710, custom high-impedance voltage monitoring or low-impedance current monitoring circuitry connected to the robot's electrical system is acceptable if the effect on the robot output is inconsequential. Blue box. A noise filter may be wired across motor leads or PWM leads. Such filtering will not be considered custom circuitry and violate neither this rule nor R712. Acceptable signal filtering must be fully insulated and must be one of the following. A 1 microfarad or less non-polarized capacitor may be applied across the power leads of any motor on your robot, as close to the actual motor leads as reasonably possible, or a resistor may be used as a shunt load from the PWM control signal feeding a servo. 8.7. Control command and signal system. R701. Control the robot with a RoboRio. A robot must be controlled via one programmable NI RoboRio or RoboRio 2.0, part numbers AM3000 or AM3000A, both versions referred to throughout this manual as RoboRio, with image version 2025 v2.0 or later. Blue box. There are no rules that prohibit coprocessors provided commands originate from the RoboRio to enable and disable all power regulating devices. This includes motor controllers legally wired to the CAN bus. R702. Communicate with the robot with a specified radio. One Vivid hosting wireless bridge, part number VH-109, that has been configured with the appropriate encryption key for your team number at each event is the only permitted device for communicated to and from the robot during the match. Events held in China and Chinese Taipei are the exemptions to this rule and must use an open mesh part number OM5P-AN or OMP5P-AC radio. R703. Use specific Ethernet port for RoboRio. The RoboRio Ethernet port must be connected to the wireless bridge port labeled Rio for VH-109 radios or 18 to 24 volt PoE for open mesh radios, either directly via a network switch, via an RPM, or via a Cat5 Ethernet pigtail. Blue box. Note: placing a switch between the RoboRio and radio may impede the ability for field staff to troubleshoot RoboRio connection issues on the field. Teams may be asked to connect directly between the radio and the RoboRio as part of troubleshooting efforts. R704. Only use allowed ports and bandwidth to communicate with the robot. Communication between the robot and the operator console may not exceed the following and is restricted to network ports listed in Table 8-5. A. 7 megabit per second for Vivid hosting wireless bridge radios, and B. 4 megabit per second for open mesh radios. Okay, then we have different ports. UDP/TCP 1180 through 1190 are designated camera data from the RoboRio to dashboard software when the camera is connected the RoboRio via USB, bidirectional yes. TCP 1735 designated for the smart dashboard, bidirectional yes. UDP 1130 dashboard to robot control data, and it's bidirectional. UDP 1140 robot to dashboard status data, and it's bidirectional. HTTP 80 camera connected via switch on the robot, bidirectional. Oh, these are all bidirectional. HTTP 443 camera connected via switch on the robot, as stated before, they're all bidirectional. UDP/TCP 554 real-time streaming protocol for H264 camera streaming. UDP/TCP 1250 CTRE diagnostic server. UDP/TCP 5800 to 5810 team use. Teams may use these ports as they wish if they do not employ them as outlined above, i.e. TCP 1180 can be used to pass data back and forth between the robot and the driver station software if the team chooses not to use the camera on USB. Blue box. Note that the 4 megabit limit will be strictly enforced by the wireless bridge. The FMS white paper has more details on how to check and optimize bandwidth usage. While it first makes every effort to provide a wireless environment that allows teams access to a full 4 megabit per second data rate with about 100 kilobit used for robot control and status, at some events, wireless conditions may not accommodate this. R705, configure devices for your team number. The RoboRio driver station software and wireless bridge must be configured to correspond to the correct team number per the procedures defined in the first robotics competition control system documentation. R706, don't bypass the arena network. All signals must originate from the operator console and be transmitted to the robot via the arena Ethernet network. R707, limited wireless allowed. The only forms of wireless communication that may be used to communicate to, from, or within the robot include A. Those required per R702 and R706. B. Tags used for location detection systems if provided by the event. And C. RFID or NFC systems used exclusively within the robot. Blue box. Devices that employ signals in the visual spectrum, e.g. cameras and non-RF sensors that don't receive human-originated commands, e.g. beam brake sensors or IR sensors on the robot used to detect field elements, are not wireless communication devices, and thus this rule doesn't apply. R708. Wireless bridge must be visible. The wireless bridge must be mounted on the robot such that the diagnostic lights are visible to field staff. Blue box. Teams are encouraged to mount the wireless bridge away from noise-generating devices such as motors, PCMs/PHs, and VRMs/RPMs. R709. Robots must have a signal light. Robots must use at least one, but no more than 2 diagnostic robot signal lights RSL, part number 855PB-B12ME522 and or AM3583. Any RSL must be A. Mounted on the robot such that it is easily visible while standing 3 feet away from at least one side of the robot, and B. Connected to the RSL supply terminals on the RoboRio, and C. If using the 855PB-B12ME522, wired for solid light operation by placing a jumper between the LA and LB terminals on the light per figure 8-16. Blue box. Please see how to wire an FRC robot for connection details. R710. Only specified modifications to control system devices permitted. The driver station software, RoboRio, PDP/PDP 2.0/PDH, PCMs/PHs, VRMs/RPMs, RLSL, 120 amp breaker, motor controllers, MXP devices used to control actuators per R713-C, relay modules per R504-B, wireless bridge, PDP/PDP 2.0/PDH breakers and fuses, servo module, power module, and battery shall not be tampered with, modified, or adjusted in any way. Tampering includes drilling, cutting, machining, rewiring, disassembling, painting, etc., with the following exceptions. Blue box. Please note that the driver station software is a separate application from the dashboard. The driver station software may not be modified, while teams are expected to customize their dashboard code. A. User programmable code in the RoboRio may be customized. B. Motor controllers may be calibrated as described in owner's manuals. C. Fans may be attached to motor controllers and may be powered from the main input terminals. D. If powering the compressor, the fuse on a spike H-bridge relay may be replaced with a VB3A-20 amp snap-action circuit breaker. E. Wires, cables, and signal lines may be connected via the standard connection points provided on the device. F. Fasteners, including adhesives, may be used to attach the device to the operator console or robot or to secure cables to the device. G. Thermal interface material may be used to improve heat conduction. H. Labeling may be applied to indicate device purpose, connectivity, functional performance, etc. I. Jumpers may be changed from their default location. J. Limit switch jumpers may be removed from a Jaguar motor controller and a custom limit switch circuit may be substituted. K. Device firmware may be updated with manufacturer-supplied firmware. L. Integral wires on motor controllers may be cut, stripped, and/or connectorized. M. Devices may be repaired provided the performance and specifications of the device after the repair are identical to those before the repair. N. The cover may be removed from the Talon SRX or Talon FX data port. O. Electrical tape may be applied to the aluminum plate inside the wireless bridge. P. The input terminal cover from the PDP may be omitted. No other element may be installed using the threaded holes to install something in place of the PDP terminal cover. Q. The RoboRio 2.0 SD card may be replaced with an SD card of any capacity. R. Adding insulating material to exposed conductors. S. Replacing control system power terminal blocks, e.g. RSL power connector, with functional equivalents. T. Tape may be applied for debris protection. Blue box. Please note that while repairs are permitted, the allowance is independent of any manufacturer's warranty. Teams make repairs at their own risk and should assume that any warranty or return options are forfeited. Be aware that diagnosing and repairing components such as these can be difficult. For more information about modification O, please see this OM5P-AC radio modification article. R711. Don't connect motor outputs to RoboRio. Neither 12-volt DC power nor relay module or motor controller output shall be directly connected to the RoboRio, with the exception of the designated 12-volt DC input. R712. Controlled PWM controllers from the RoboRio. Every relay module per R504-B, servo controllers, and PWM controllers shall be connected to a corresponding port. Relays to relay ports, servo controllers, and PWM controllers to PWM ports on the RoboRio, either directly or through a WCP Spartan sensor board or via a legal MXP connection per R713. They shall not be controlled by signals from any other source, with the exception of the NIDAC Dynamo motor controller, which must also be connected to the RoboRio digital I/O port. R713. Only approved MXP devices can control actuators. If a motor is connected via the MXP, its power regulating device must be connected by one of the following methods. A. Directly to any PWM pins. B. Via a network or passive conductors used to extend the PWM pins. Or C. Via one approved active device. A. Kawai Labs Navex MXP. B. Kawai Labs Navex X2 MXP. C. RCal MXP daughter board. D. Rev Robotics Rio Duino. E. Rev Robotics Digit board. F. West Coast Products Spartan sensor board. G. Husky Robotics Husky 2.0 board. Blue box. A passive conductor is any device or circuit whose capability is limited to the conduction and or static regulation of the electrical energy applied to it, e.g. wires, splices, connectors, printed wiring boards, etc. An active device is any device capable of dynamically controlling and or converting a source of electrical energy by the application of external electrical stimulus. The network of passive conductors only applies to the pins being used for PWM output to motors or servos. This means that connecting an active device such as a sensor to one MXP pin does not prevent other MXP pins from being used in accordance with B. R714. Control CAN motor controllers from the Robo-Rio. Each CAN motor controller must be controlled with enable/disable inputs sourced from the Robo-Rio and passed via either a PWM wired per R713 or CAN bus, either directly or daisy-chained via another CAN bus device signal, but both shall not be wired simultaneously on the same device. Blue box. As long as the CAN bus is wired legally so that the heartbeat from the Robo-Rio is maintained, all closed-loop control features of the CAN motor controller may be used. That is, commands originating from the Robo-Rio to configure, enable, and specify an operating point for all CAN motor controller closed-loop modes fit the intent of R701. Wired directly includes via any series of passive conductors, i.e. star or hub configurations, using only passive conductors are permitted. R715. Control PCM/PHs from Robo-Rio. Each PCM/PH must be controlled with signal input sourced from the Robo-Rio and passed via a CAN bus connection from the built-in CAN on the Robo-Rio, either directly or daisy-chained via another CAN bus device. R716. Don't alter the CAN bus. No device that interferes with, alters, or blocks communications along the Robo-Rio and the PDP/PDH, PCM/PHs, and or CAN motor controllers on the bus will be permitted. Blue box. Only one wire should be inserted into each Weidmuller CAN connector terminal. For documentation on how to wire the CAN bus connectors, see How to Wire an FRC Robot. R717. USB to CAN adapter permitted. Additional CAN bus connections may be added to the Robo-Rio using the CTR Electronics Canivore, part number 21-678682 or WCP-1522, USB to CAN adapter. Blue box. Any additional CAN bus added in this manner satisfies the requirements of R714, i.e. you may connect motor controllers to this additional bus. 8.8. Pneumatic system. In order to maintain safety, the rules in this section apply at all times while at the event, not just while the robot is on the field for matches. R801. Only use explicitly permitted pneumatic parts. To satisfy multiple constraints associated with safety, consistency, inspection, and constructive innovation, no pneumatics parts other than those explicitly permitted in this section shall be used on the robot. R802. No custom pneumatics and meet minimum pressure ratings. All pneumatics items must be COTS pneumatics devices and either A. Rated by their manufacturers for pressures of at least 125 psi or B. Installed downstream of the primary relieving regulator CR809 and rated for pressure of at least 70 psi. Blue box. Any pressure specification such as working, operating, maximum, etc. may be used to satisfy the requirements of this rule. It is recommended that all pneumatic items be rated by their manufacturers for a working pressure of at least 60 psi. R801. Don't modify pneumatics. All pneumatics components must be used in their original unaltered condition. Exceptions are as follows. A. Tubing may be cut. B. Wiring for pneumatic devices may be modified to interface with the control system. C. Assembling and connecting pneumatic components using the pre-existing threads, mounting brackets, quick connect fittings, etc. D. Removing the mounting pin from a pneumatic cylinder, provided the cylinder itself is not modified. And E. Labeling applied to indicate device purpose, connectivity, functional performance, etc. Blue box. Do not, for example, paint, file, machine, or abrasively remove any part of a pneumatic component. This would cause the part to become a prohibited item. R804. Only use specified pneumatic devices. The only pneumatic system items permitted on robots include the following items. A. Pneumatic pressure vent plug valves functionally equivalent to those provided in the kit of parts. Blue box. Examples of acceptable valves include Parker PV609-2 or MV709-2. B. Pressure relief valves functionally equivalent to those provided in the kit of parts. Blue box. Examples of acceptable valves include Norgren 16-004-011, 16-004-003, or McMaster-Carr 48435 K714. To be considered functionally equivalent to the valve must be preset or adjustable to 125 psi and capable of relieving at least 1 SCFM. C. Solenoid valves with a maximum 1/8 inch nominal, NPT, BSPP, or BSPT port diameter, or integrated quick connect 1/4 inch outside diameter tubing connection. D. Additional pneumatic tubing with a maximum 1/4 inch outside diameter. E. Pressure transducers, pressure gauges, passive flow control valves, specifically needle valve, manifolds, and connecting fittings, including Koch pneumatic U-tubes. F. Check and quick exhaust valves, provided that the requirements of R813 are still met. G. Shutoff valves which relieve downstream pressure to atmosphere when closed may also be known as three-way or three-way exhausting valves. H. Pressure regulators with the maximum outlet pressure adjusted to no more than 60 psi. I. Pneumatic control cylinders, pneumatic linear actuators, and rotary actuators. J. Pneumatic storage tanks, with exceptions of white clippered tanks, part number ABT-PP-41. K. One compressor that is compliant with R806. L. Debris or coalescing water filters. And M. Venturi valves. Note, the high-pressure side of a Venturi valve is considered a pneumatic device and must follow all pneumatic rules. The vacuum side of a Venturi valve is exempted from the pneumatic rules per A in the blue box below. Blue box. The following devices are not considered pneumatic devices and are not subject to pneumatic rules, though they must satisfy all other rules. A. A device that creates a vacuum. B. Closed-loop Koch pneumatic gas shocks. C. Air-filled pneumatic wheels. And D. Pneumatic devices not used as part of a pneumatic system, i.e. used in a way that does not allow them to contain pressurized air. R805. If using pneumatics, these parts are required. If pneumatic components are used, the following items are required as part of the pneumatic circuit and must be used in accordance with this section, as illustrated in Figure 8-17. A. 1 first robotics competition legal compressor per R806. B. A pressure relief valve per R804-B, connected and calibrated per R811. C. A Nason pressure switch part number SM-2B-115R/443 and or Rev Robotics analog pressure sensor part number Rev-11-1107, connected and wired per R812. D. At least 1 pressure vent plug plumbed per R813. E. Stored pressure gauge and working pressure gauge per R810. And F. 1 primary working pressure regulator per R808. R806. Compressed air from robot compressor only. Throughout an event, compressed air on the robot must be provided by its one onboard compressor only. Compressor specifications must not exceed nominal 1.1 cubic feet per minute. Flow rate at 12 volt DC at any pressure. Blue box. A robot's compressor may be substituted by another compressor, but a robot may only have one designated compressor at a time, and all compressed air on the robot must be sourced from a single compressor. Note: Vi-Air C-Series compressors, which have a max working pressure of 120 psi, are rated for intermittent pressures greater than 125 psi and therefore meet the requirements of this rule. R807. Air storage pressure limit. Stored air pressure on the robot must be no greater than 120 psi. No stored air pressure intended for the robot may be located off-board the robot. R808. Working air pressure limit. Working air pressure used to actuate devices on the robot must be no greater than 60 psi and must be provided through a single primary adjustable relieving pressure regulator. Additional regulators may be located downstream of the single primary regulator. Blue box. Examples of acceptable valves include Norgren regulator part number R07-100-RNEA and Monier part number 101-3002-1. R808. Limited devices at high pressure. Only the compressor, relief valve, pressure switch, pressure vent plug, pressure gauge, storage tanks, tubing, pressure transducers, filters, and connecting fittings may be in the high-pressure pneumatic circuit upstream from the regulator. Blue box. It is recommended that All components in the high-pressure pneumatic circuit upstream from the regulator be rated for at least 115 psi working pressure. R810. Pressure gauges must be visible. Pressure gauges must be placed in an easily visible locations upstream and downstream of the regulator to display the stored and working pressures, respectively. Pressure gauges must show pressure in psi, kPa, or bar. R811. Relief valve requirements. The relief valve must be attached directly to the compressor or attached by legal hard fittings, e.g. brass, nylon, etc., connected to the compressor output port. Teams are required to check and/or adjust the relief valve to release air at 125 psi. The valve may or may not have been calibrated prior to being supplied to teams. Blue box. Instructions for adjusting the pressure relief valve can be found in the pneumatics manual. R812. Pressure switch requirements. The pressure switch must be connected to the high-pressure side of the pneumatic circuit, i.e. prior to the pressure regulator, to sense the stored pressure of the circuit. It must be either A. Nason part number SM-2B-1155R/443, wired as described, and or the two wires from the pressure switch must be connected directly to the pressure switch input of the PCM/PH, controlling the compressor, or, if controlling using the Robo-Rio and a relay, to the Robo-Rio. If connected to the Robo-Rio must be programmed to sense the state of the switch and operate the relay module that powers the compressor to prevent overpressuring the system. B. Rev Robotics part number Rev-11-1107, wired as described. The analog output of the sensor must be connected directly to analog input 0 of the PH with firmware version 22.0.2 or newer, controlling the compressor. Blue box. The Rev Robotics analog pressure sensor may only be used with pH compressor control and may not be used with PCM compressor control. R813. Vent plug requirements. Any pressure vent plug must be A. Connected to the pneumatic circuit such that when manually operated it will vent to the atmosphere to relieve all stored pressure in a reasonable amount of time, and B. Placed on the robot so that it is visible and easily accessible. R814. Don't connect solenoid outputs together. The output air from multiple solenoid valves must not be combined. Blue box. Manifolds, shuttle valves, and other devices which do not combine output airflow, even though it may be plumbed into the same device, are not violations of this rule. 8.9. Operator console. R901. Use the specified driver station software. The driver station software provided by National Instruments installation instructions found here is the only application permitted to specify and communicate the operating mode, i.e. auto/teleop, and operating state, enabled/disabled, to the robot. The driver station software must be version 25.0 or newer. Blue box. Teams are permitted to use a portable computing device of their choice, laptop, computer, tablet, etc., to host the driver station software while participating in matches. R902. The operator console must have a visible display. The operator console, the set of components and mechanisms used by the drivers and or human players to relay commands to the robot, must include a graphic display to present the driver station software diagnostic information. It must be positioned within the operator console so that the screen display can be clearly seen during inspection and in a match. R903. Connect FMS Ethernet directly to the operator console. Devices hosting the driver station software must only interface with the FMS via the Ethernet cable provided at the driver station, e.g. not through a switch. Teams may connect the FMS Ethernet cable to the device running the driver station software directly via an Ethernet pigtail or with a single port Ethernet converter, e.g. docking station, USB Ethernet converter, Thunderbolt Ethernet converter, etc. The Ethernet port on the operator console must be easily and quickly accessible. Blue box. Teams are strongly encouraged to use pigtails on the Ethernet port used to connect to the FMS. Such pigtails will reduce wear and tear on the device's port and will, with proper strain relief employed, will protect the port from accidental damage. R904. Operator console physical requirements. The operator console must not A. be longer than 5 feet, B. be deeper than 1 foot 2 inches, excluding any items that are held or worn by the drivers during the match. C. Extend more than 6 feet 6 inches above the floor, or D. Attach to the field except via the loop tape as described in section 5.6.1 driver stations. Blue box. There is a 4 foot 6 inch long by 2 inch nominal wide strip of hook and loop tape loop side along the center of the driver station support shelf that should be used to secure the operator console to the shelf. See section 5.6.1 driver stations for details. Please note that while there is no hard limit, operator consoles that weigh more than 30 pounds will invite extra scrutiny as they are likely to present unsafe circumstances. R905, field wireless only. Other than the system provided by the field, no other form of wireless communications shall be used to communicate to, from, or within the operator console. Blue box. Examples of prohibited wireless systems include, but are not limited to, active wireless network cards and Bluetooth devices. For the case of the first robotics competition, a motion sensing input device, e.g. Microsoft Kinect, is not considered wireless communication and is allowed. R906. No unsafe operator consoles. Operator consoles shall not be made using hazardous materials, be unsafe, cause an unsafe condition, or interfere with other drive teams or the operator console of other robots. R907. No AC inverters. Operator consoles must not contain AC inverters.